Often in mathematics we're asked to graph algebraic equations, in this case y equals 3x minus 2. But how do we do that? How do we take those symbols and put them into a picture? Well, let's first of all consider some numbers. So if we put x equals 5 into that equation, we know that y will be equal to 3 multiplied by 5 minus 2, and that comes to 13. We also know that if we put in another number like negative 2 where the x is, we get that y equals 3 multiplied by negative 2, take 2. Of course 3 multiplied by negative 2 is negative 6, and if we take a further 2 that becomes negative 8. So the question now becomes, how do we graph these results onto our set of axes which we can see in this picture? You'll notice on our graph that we do assume that you know that all the x values go on the horizontal axis and all the y values will go onto the vertical axis. Now we need to form a table of values so we can actually put some points onto our graph. The question then becomes, how many values do we need to place in the table? Well, this is a straight line graph. Y equals 3x minus 2 represents a straight line. And if we're going to graph a straight line, you ultimately need 2 points, because if you've got 2 points you can join them up to form a line. What would be wise to do would be to plot another point, because if we've made an algebraic error, by finding a third point we'll be able to find evidence that we've made a mistake and we need to go back and check our results. If we have done everything correctly, we should find evidence that the 3 points are all on the same line. So let's reduce our grid now to a table of 3 values, and what we'll do is we'll choose x values that are split across the graph. So in other words, a negative 2 on the negative x values, a 0 right in the center of our graph, and 3 represents values on the positive side. Now when we substituted x equals negative 2 into our equation, we found previously that y was equal to negative 8. If we substitute 0 into our equation, y equals negative 2. And if we substitute 3 into our equation, y equals positive 7. We now have 3 pairs of values, or 3 points, that we can use on our graph to form a line. So going back to the original axes that we had, this time we'll put some values on there to represent the scale. We've drawn our y-axis to go from negative 8 to 12, and every square represents 2 units. On the x-axis, we've spread it out a little bit more. So every square there represents half a unit, or every 2 squares represents 1 unit. And our x-axis goes from negative 2 to positive 3. Now to plot the points. We've got our 3 pairs of values, or 3 points above the graph there, and the first one we've got is negative 2, negative 8. So just to remind ourselves, when we're plotting points, we go horizontally first, in this case negative 2 on the x-axis, and then we go vertically, in this case down to negative 8 on the y-axis. And an easy way to remember that is whenever you're plotting points, you need to walk into a building before you go up or down the lift. So there's our point negative 2, negative 8. We repeat the process with 0, negative 2 and 3, positive 7. And it would be wise to pause here to see if you agree with the placement of those points. Once we've positioned the points, we can then draw our line. We do this by joining the 3 points in a straight line and then extending the line so it goes right across our graph. We also put arrows at the end of our line, which indicates that it keeps going. It's not just the points that we've drawn that's the line. We can have points for x which extend to positive infinity and negative infinity. So the arrow indicates that this line keeps going and is true for all x and y values on this line. For example, if we have a look at our graph, if we look at where x equals 1, we should find that that also matches with y equals 1. And that's because if you substitute 1 into y equals 3x minus 2, 3 times 1 equals 3, and then 3 minus 2 equals 1, which gives you the y value.